Okay, good evening and welcome to everyone. This is the NOAA Planet Stewards April 2018 webinar, Meteorological Memories, the Hazardous Weather of 2017 and How to Prepare for the Future. My name is Bruce Moravchik and I will be your host for this evening. We are very proud and very pleased and very honored to have Greg Carbon, the Chief of Forecast Operations for NOAA's Weather Operations Center. For those of you who haven't joined us before, we have some opening announcements. Then Mr. Carbon will have his presentation, and I have some important closing announcements. So please stay on the line. So tonight's broadcast is being recorded, and we will be sending a link out to the video archive within a week of the presentation. If you don't receive a link to the archive, send me an email with the subject, request link April 2018 webinar. There is a video archive, and all of the slides that are currently presented tonight and of previous broadcasts are currently available on the NOAA Planet Stewards Google website. You may not be able to copy down the link here, but you'll definitely be able to get it from the archive when we send it to you. We've got webinar archives and slides going all the way back to 2013 from monthly presentations. Now, if you can't access that Google website, you can send an automated access request through Google, or you can send me an email saying that you want access to the Google site. For this webinar, we have so many attendees this evening that your microphones are going to be muted. If you'd like to ask myself or Mr. Carbon a question, please type it into the GoToWebinar control panel on the right-hand side of your screen. Now, during tonight's broadcast, you're going to be receiving an email from me with a link to a post-webinar poll. Please answer it. We do look at every single response, and it does provide us with important information and metrics that help us with future events. Now, for those of you who stay on for the entire presentation time and for the announcements, we have a certificate of attendance that will acknowledge that you have participated in one contact hour of professional development through the NOAA Planet Stewards Education Project. We have some upcoming dates for you. Tuesday, May 15th at 7:30 p.m. Eastern Time. This is a different time than usual. It's Tuesday, May 15th. Our next webinar, Water Quality, Shellfish, and You. And then Monday on May 21st at 8 p.m. Eastern Time, we have our next book club meeting, Please Don't Paint Our Planet Pink, by Greg Kleiner. And there's the link where you can find out more about the book. If you'd like to join the discussion, you need to contact Stefan at gmail.com. Okay, that's at gmail.com. If you have any questions about any of this, please send me an email. Now, for those of you who are looking for something to do this summer, we have several workshops lined up, some things that you might like to take advantage of. The Changing Southwest Environment, Trends and Challenges is going to be a 3-day workshop for educators, June 11th through 13th in Flagstaff, Arizona. You will have subject matter experts, scientists, communicators, and educators talking to you about understanding complex systems, applying systems thinking to regional issues of the area like extreme weather, fire, drought, flooding, and ecosystem dynamics. This is going to be a terrific workshop. I certainly urge any of you that feel that you can participate to participate. There is a very, very low registration fee for all of our Planet Stewards workshops. Now, for those of you who might be in the Texas area, more specifically in the Houston, Galveston area, we have another workshop going on June 25th through 28th, Environmental Impacts to the Gulf Coast. What do we know? What can we do? This is going to be focused on understanding climate change and ocean acidification and impacts to the Gulf of Mexico. Now, There's a link there, and also there will be credits that will be provided for educators within the Texas educational system. And for those of you who will find themselves on the Hawaiian Islands this summer, we also will be working with the Hawaiian Environmental Education Alliance on another workshop, July 21st, really through the 23rd, Resilience, Education, and Action, Our Place in a Changing World. Focus will be on citizen science, developing quantifiable research projects, active STEM experiences, and connecting diverse audiences through cultural practice. The pre-symposium on the 21st through 22nd is going to be open to 40 educators, and the symposium, the full-day symposium on the 23rd, is unlimited in terms of the numbers that can join. And the pre-symposium, there's going to be a special opportunity for K through 12 teachers to gain ongoing credits, graduate credits as well. And this will be in both will be in the Honolulu area on Oahu, Hawaii. And if you are closer to the East Coast, though Planet Stewards is not sponsoring this in particular, NOAA, Sea Grant, Delaware, and Made Clear will be having a Climate Change Academy at the University of Delaware in Lewes, Delaware on Monday, May 21st. There's going to be a self-paced online component, and there's going to be a face-to-face component on June 26th through 28th. It's going to be focusing on talking to climate change, climate science experts, using three-dimensional learning-based lessons in field studies, impacts on ecosystems, cities, farms, coast, and you'll not only will be getting free educational materials, but there is a $300 stipend for every educator that completes all the requirements. And there are additional certification hours that can be gained. So it's a pretty good deal. But I do not want to take any more time away from the presentation that you are here to see, Mr. Greg Carbane. So I am now going to turn the mic over to him so he will be able to show his screen, and I will introduce him. So Greg, the mic is yours, and I shall introduce him. Now, Greg Carbane, he serves as Chief of Forecast Operations for NOAA's National Weather Service Weather Prediction Center in College Park, Maryland. He oversees a staff of over 30 meteorologists issuing rainfall, snowfall, and medium-range forecasts for the nation. Prior to moving to Maryland, Greg was the warning coordination meteorologist at NOAA's National Weather Service Storm Prediction Center in Norman, Oklahoma, and he was doing that since 2007. Greg's career in meteorology and weather forecasting has spanned more than 30 years, and he's performed in a variety of operational capacities from local to national scale. Mr. Carbane is a 1985 graduate of Linden State College in Vermont, and in addition to graduate coursework at the University of Oklahoma, is a 2011 graduate of the U.S. Department of Commerce's Executive Leadership Development Program. Kudos, Mr. Carbane. That is a difficult program. Greg most recently appeared in the 2018 PBS Nova production of Prediction by the Numbers, where he spoke about numerical forecasting and ensemble modeling. And with that introduction, Mr. Carbane, the floor is yours.
Well, thank you very much, Bruce. And you can hear me fine?
Sound great.
Great. All right. Well, good evening, everyone. I'd like to thank Bruce and the Planet Stewards for the invitation to present to the webinar this evening, and appreciate the very nice introduction there. So this presentation is long run. I started in 2003 with a presentation to the local chapter of the American Meteorological Society in Omaha, Nebraska. And since then, I've updated it every year and presented it at various venues, including the National Weather Association annual meeting every year. My wife calls it my shtick, and so hopefully you will enjoy the show here. The list of events is not officially sanctioned by NOAA. These are my memories of interesting meteorological events throughout the year, and I'll present them in approximately chronological order. And I've already begun my list for 2018, but just a reminder, these are the 10 top events that I came up with for 2017. So we're talking a little over a year ago for many of these events. So let's get underway. So the Sierra snowfall from last winter was simply incredible. They've had much less snow this past winter, but seasonal totals last winter were over 600 inches at a number of locations, and these amounts are equivalent to snow piling up to a height of about a 5 or 6 story building. This satellite loop is depicting water vapor imagery in the atmosphere during about a 10-day period in early 2017. And you can observe how the rich moisture from the tropics is pulled northward toward the west coast by transient weather systems in the mid-latitude jet stream. And it's this process over a period of many days and weeks that contributed to the amazing amounts of precipitation over California last winter. The moisture in the atmosphere is evident in this evaluation here. The map on the left is a rough approximation of water vapor transported across California during a normal January, while the map on the right shows what was estimated to have occurred in January of 2017, generally about 2 to 3 times above normal moisture transported into this portion of California. This is based on what we call reanalysis data. The moisture in the atmosphere is delivered by what are called atmospheric river events, and you can see on the left that from late 2016 into early 2017, more than 40 of these atmospheric river events were documented along the west coast of the United States. The chart on the right hand of the screen shows a composite of cumulative precipitation in 8 locations over Northern California. The average for any period from October 1 through early May is shown by this light blue curve here in the middle of the chart. And you can see where 2016-17 established a new record high in terms of precipitation across this area of California, with over 90 inches measured at the 8-station index through April of 2017. The precipitation resulted in a nearly complete eradication of the incredibly devastating drought that was in place across much of California. And you can see the chart from March 2013 through 2016, how the area of exceptional drought expanded to encompass most of the state. However, by March 2017, drought conditions had all but disappeared. Of course, the downside of all this precipitation coming over such a short period of time were that there were many flooding events, and with the all-time January through March precipitation total at Sacramento, you can see here a new record high established in terms of total precipitation there. And then the Oroville Dam, which is near Sacramento, the spillway was damaged considerably by overflow from the reservoir there, and many areas also sustained substantial flood damage during the first part of the year. So even though this was beneficial in some respects, the resulting flooding was quite dramatic. And there were other impacts further down the road that we'll talk about here as well. So while the drought was busted, the February floods ended up costing over $1 billion. And this was basically the first $1 billion flood disaster for 2017. Memory number 2, I call plastered in Portland. An unexpectedly crippling snowstorm hit Portland, Oregon last January. And this was the city's heaviest snowstorm since February of 1995 and led to abandoned vehicles on snow-choked roads in and around the metropolitan area. This was one of many winter events to impact the Northwest during early 2017. You can see from the map of temperature departures on the right that January 2017 saw above normal temperatures across much of the lower 48 states. And one of the few exceptional areas of the country where temperatures were below normal was across the Pacific Northwest and the interior Northwest and Northern Rockies, where the monthly average temperature in some places was about 10 degrees below normal. I'll describe this particular storm coming on January 11th, 2017. The colder than normal conditions around parts of Washington and the Columbia River Valley, which you see here in this plot. This very cold air tends to drain westward from the along the Columbia River Valley toward the Portland area. And that's what happened during this event. At the same time, we saw low pressure develop over the eastern Pacific here in the right-hand loop. And this low pressure system brought moisture and lift up over that cold air. And this storm brought the incredibly heavy snowfall for this area of Portland during this event over about a 24-hour period. This satellite loop shows the developing storm system as well, and the observations essentially changing from rain, a little bit difficult to see there. R minus is light rain to S minus or S plus, which is light to heavy snow. And the Portland area picked up nearly a foot of snow during this time, making for a beautiful view after the storm's passage, but a nightmare for travelers during the event. AWSSI stands for the Accumulated Severity. It's measuring objectively how hard the winters are based on climatology. Clearly, one of the more extreme winters on record for the Northwest U.S. occurred during the winter of 2016-2017, according to the index values here. You can see one of the few areas in the country to experience a pretty significant winter. So in summary, it was the 7th coldest January on record for Portland, Oregon, and the January snowstorm was the biggest snow that they had had in over 20 years, and the 5th largest 24-hour snowfall at the Portland airport. So we're going to go from snow to ice to fire. In early March 2017, this was a particularly devastating day across parts of the southern high plains from West Texas into Kansas. And one very bad day occurred on March 6th. As you see the headline here, wildfires in 4 states kill 6 people and force thousands from their homes. So let's take a closer look at the meteorology leading up to and during this event. In some ways, wildfires are kind of the opposite of floods with respect to meteorology. You need very moist antecedent conditions above normal soil moisture to exist for flooding events. For wildfires, you need just the opposite, very dry and warm conditions. And the map on the left shows how little precipitation occurred during the month leading up to the wildfires. Very low precipitation occurring across parts of the Central Plains here. And then the map on the right shows how warm the temperatures were during the event, or in the days leading up to the event, basically 2 to 4 degrees higher than normal for this time of year across parts of the Texas Panhandle, northeast across Oklahoma and parts of Kansas. Very warm temperatures for early March. Fires also need fuel, and the drier the fuel, the more dangerous the potential fire. And so given the dry fuels and warm weather in place across this central part of the United States, the U.S. Forest Service a relatively large area from eastern New Mexico up across Kansas. The surface weather map on the right shows a strong cyclone, and that was developing across the Dakotas, and the intensifying westerly winds on the south side of this cyclone basically cross the Rockies and then come downslope into the plains, causing very warm and very dry conditions, extremely low relative humidity just to the west of the dry line, which is this line indicated here. It looks a little bit like a warm front, but it's known as a dry line. And that's where the fires and the winds, or the wind and the dry weather combine to produce extreme fire weather conditions. The radar loop here shows a developing thunderstorm squall line, which is associated with the cold front and the cyclone to the north. But before the squall line and its associated wind shift spreads to the southeast, you can see smoke plumes in the radar imagery. Numerous wildfires erupted across the northeast Texas Panhandle, up across Kansas here. And one of the most dangerous conditions for a wildland firefighter in these situations is a rapid wind shift. And that's exactly what happened to these fires late on the evening of March 6th. The map on the right is a snapshot of the radar, and you can see the smoke plumes here. This is not precipitation. This is all from smoke showing up on radar. And this also shows a fire potential index called the Fosberg Fire Weather Index. And this is valid for late in the afternoon on March 6th. Any values in the Fosberg index above 75 indicate that extreme fire behavior is likely due to a combination of wind, relative humidity, and temperature. That wasn't the only day with fires in March, and there were other fires, mostly across the plains during the month, and this pushed the average acreage burn to new highs. While the number of fires was slightly below normal on the chart here, you can see the red line here, the fires were unusually large in size, a lot of acreage burned, and so that set a new record for acreage burned during the month of March back to 2000. Memory number 4. For the mid-Atlantic region during last winter, similar to this most recent winter, there were few opportunities for a good old-fashioned snowstorm. And for those who might know that this talk is kind of one of the traditions I have in my meteorological memories is to include at least one nor'easter every year, because these are the storms that got me interested in meteorology. So we didn't have a lot of opportunity, but we did have one in mid-March come along. Looked like it had some potential to be a pretty big storm. And the radar loop on the left depicts the evolution of the system along with the various National Weather Service watches and warnings that were issued during the event. And then the snowfall totals are shown on the right. And some of these areas picked up incredible amounts of snow, as we'll see, but not necessarily in the areas that were initially forecast. So we were excited for the potential for a nor'easter, but then there were some issues with respect to whether it actually verified. So the media was not very happy either, but ahead of this particular snowstorm, especially across some of the major metropolitan areas. Early forecasts for Philadelphia and New York areas were on the high side, and many were disappointed there wasn't more snow for these locations after the storm was advertised to be a blizzard in some of these areas. Well, the blizzard did happen, only it was a bit farther to the west and removed from the I-95 corridor. And from a strictly probabilistic sense, these forecasts were not too bad. The table at the top shows the forecast probability of 4 inches or more of snow falling at Washington, D.C., Philadelphia, New York City, and Boston. And while it could be argued that Washington, D.C. probability was a bit on the high side for what was observed, the higher probabilities and confidence in more than 4 inches of snow worked out well elsewhere from Philadelphia to Boston. And the bottom table shows the probability of exceeding a foot of snow here at these locations. And while no location had greater than 50% chance for more than a foot of snow, and you see here where the verified amounts in red came in well below that amount. But you didn't have to go very far. Where the snow did fall heavily was in Binghamton, New York. And this loop is a time lapse, or this time lapse video shows you the snow as it piled up during this remarkable event across parts of the southern tier of New York up through the Catskills and parts of New England. We'll run it one more time here. You see the boughs of the tree limbs there sagging under the weight of the snow, and all the objects on the deck essentially disappearing under a blanket of white here. And with daybreak comes a beautiful scene with a lot of shoveling. So it was a great snowstorm, not the greatest for areas from DC to Boston, but certainly pretty impressive as you went inland from those areas here. Regarded as a major snowstorm on the northeast. And it was the biggest snowstorm in Binghamton, New York's history, almost 3 feet of snow falling from beginning to end with this event. On to number 5, the Ozarks, Missouri spring flood. Spring flooding comes to the Midwest quite frequently, but this event really stands out in terms of the magnitude of the amount of rainfall that fell over such a short period of time. I'll show you the satellite loop here, shows a deep spring storm system triggering widespread thunderstorms from Oklahoma to Ohio at the end of April 2017. And the upper level map here on the right shows the low pressure system basically becoming closed off as it moves toward the Texas panhandle there. And that essentially slows down the entire eastward motion of the storm system and allows tremendous amounts of moisture to be pulled northward from the Gulf of Mexico across parts of Arkansas and Missouri and released in the form of extreme rainfall with this event. The 24-hour rainfall totals 5 inches in those areas that go to blue on the map. And these are very rare 24-hour amounts, very unusual to see such large amounts over a large area like this. And in fact, the red indications on the maps on the right are an indication of rarity of the event. So for the rainfall totals across parts of the Ozarks, southern Missouri, into the Ohio Valley here, those amounts are basically a 1 in 10-year chance or a 10% recurrence interval in any year. So pretty unusual event here. And even more unusual if you look at the higher end events, maybe 9 to 11 inches isolated here from southern Missouri across southern Indiana. And that's less than 1% chance of occurrence in any year. So this was a really pretty unusual event, even though it does rain heavily in these areas during the spring. It doesn't rain all that heavy as what we saw at the end of April 2017. And this map just depicts the 2-day rainfall intervals, more 24-hour amounts. And of course, the results were widespread flooding. A lot of levees in this area were overtopped. One of them in the Pocahontas, Arkansas area here, and there's an aerial photograph showing the widespread flooding affecting the downtown area of Pocahontas, and on the Google map on the right here showing the road closures due to the flooding in this area of northeast Arkansas in late April. So with up to 15 inches of rain over a multi-state region in the Midwest, this caused historic river flooding and was most severe in Missouri and Arkansas, southern Illinois, where levees were breached, towns were flooded, and there was widespread damage to homes, businesses, and infrastructure. This was the second billion-dollar flood event of 2017. I'm going to pick up the pace a little bit here. Number 6 is a quick but devastating hailstorm that hit Denver on May 8th, 2017. It turns out this was but only due to very large hail. And the image on the left is called a skew-T diagram. Meteorologists use this chart to assess the vertical temperature profile in the atmosphere. The red line is the temperature and the green line is the dew point temperature as you go aloft in the atmosphere, a measure of moisture. Calculations from this chart can reveal atmospheric instability or the tendency of air parcels to rise. Furthermore, the magnitude or strength of that instability can be used to estimate the speed at which air parcels will rise vertically in a thunderstorm updraft. Very high instability was present on this day, and it's entirely possible that the thunderstorm updraft speeds were exceeding 100 miles an hour. And you need these vertical winds for the production of large hail. Since large hailstones usually take several trips up and down through a thunderstorm, in order for those stones to grow to the extent we've seen on this day, the thunderstorm updrafts were particularly intense. And you can see that by the satellite image in the middle here, visible satellite showing tops well up into the atmosphere and numerous storms moving across the Front Range of Colorado. One of these happened to move across the Denver metropolitan area, damaging cars, homes, and vegetation, and resulting in the $1 billion in damages on this particular May day. The monsoon thunderstorms, number 7 here across the southwest U.S., usually become active by July and persist through August. And 2017 was really no different. There were many days with active storms and locally heavy rainfall. One day in particular, though, July 15th, was especially bad when an isolated and slow-moving thunderstorm cell developed north of Payson, Arizona. It was later estimated the storm produced between about 1 inch or 2 of rainfall across what was called the Highline burn scar. In many instances across the remote western U.S., this might have gone unnoticed. However, several miles downstream from the burn scar here, along the East Verde River, there was a popular swimming hole shown here in the middle photo. The heavy rain on the burn scar contributed to a debris flow that moved rapidly downstream and violently moved into the swimming hole area with no advance warning. Unfortunately, 10 fatalities occurred when people were swept away and drowned during this event in mid-July. Number 8, well, we won't forget Harvey anytime soon, especially for those across Texas and the Houston area, but also the meteorologists who watch this event unfold. This particular loop is a derivation from satellite imagery trying to indicate the amount of moisture contained within a tropical cyclone, and it shows Harvey's advance on the middle Texas coast during the waning days of August 2017. And while landfall and wind and surge produced significant property damage near Corpus Christi, Texas, it was the slow movement of this tropical cyclone that produced unprecedented flooding across Houston, Beaumont, Port Arthur, Texas. A rainfall record for a tropical cyclone, near 60 inches of rainfall, breaking previous records. And it's the recovery from this event is continuing and ongoing in some of these areas even months later. This was the third billion-dollar flood of 2017, and again, a pretty remarkable event to watch. As a meteorologist trying to forecast this event, the 5-day rainfall totals were just hard to imagine. On to number 9. Hurricane Irma comes in as memory number 9. This is sort of a composite of satellite images of Hurricane Irma. Shows the track of Irma across the Caribbean and toward Florida at the end of August and through the first 10 days of September. The next image I'm going to show you will be an incredible zoom from NOAA's new GOES-16 satellite. Actually, the GOES-16 satellite started providing imagery in 2017 on an operational basis, and basically for all of these events, there's just incredible satellite imagery coming from the GOES-16 satellite. This next image will be centered right on in that square there on September 6th, 2017. This is the time that the small island of Barbuda was in the eye of Irma. However, the island was only halfway through its nightmare here. They had just experienced several hours of winds exceeding 150 miles an hour, and the backside of the storm would soon move over the island as well. This is essentially bringing an EF4 tornado for many hours across the area, and it obviously completely devastated the island. Of course, as we now know, Miami was spared a similar fate. However, in the days before Irma's Florida landfall, I worked with other dedicated National Weather Service meteorologists to establish backup capability for the Miami National Hurricane Center in the event they were taken down by Irma. And we have backup capability for the Hurricane Center here at the Weather Prediction Center in College Park, where I work. And the support center in early September. We brought in hurricane forecasters from Miami and Hawaii and elsewhere, and in the event that the Hurricane Center in Miami went down, we were prepared to carry on the mission here from College Park. Luckily, this did not happen, but we certainly learned a lot and are better prepared in the event we need to do this again someday, but hopefully not. And there's still a lot of folks struggling to recover from the hurricanes of 2017. Here's where you can donate to hurricane relief if you're so inclined. Hand in hand, a benefit for hurricane relief is still accepting donations. So number 10, it's time for number 10. This will be another unfortunate episode of wildfires, only this time we'll end up in the same place we started, in California. And while the copious rainfall and snowfall early in the year was mostly beneficial in eradicating the drought, it also boosted the growth of vegetation. By later in the fall, when the temperatures remained warm but moisture was sparse, some of this vegetation turned into fuel for fires. And the fires continued into December, and California ended up tallying its most destructive year for wildfires with over $9 billion in insured losses from at least 250 fires. And perhaps the most sobering statistic from this year-ending memory is that 25% of the most destructive wildfires in California's history happened to occur in the last 70 days of 2017. So there you have it, my meteorological memories, the 10 of them for 2017. And so I think we will Before moving on here, Bruce, if it's okay with you, I go ahead and take any questions related to this content, and then we can go on and talk a little bit about the National Weather Service education links and websites available for more information.
Thanks, Greg. So if you do have any questions, as I've mentioned before, please type them into your question panel, and I'll narrate them to Greg. One question that we do have that came in was, how does this time period, Greg, compare to similar periods in terms of the amount of extreme weather? And if so, what do you think that means?
Well, I've been doing this now almost 15 years, and every year presents some pretty remarkable events, extremes and otherwise. One thing with my move from the Storm Prediction Center to the Weather Prediction Center is I've certainly become more focused on heavy rain events as opposed to tornado and severe storm events. So got a lot of experience in severe storm forecasting over the years at the Storm Prediction Center, and there were very few years in which there weren't a handful of incredibly damaging tornado events. Years busier than others, and there's a lot of variability in that statistic. Rainfall, on the other hand, is a real challenging forecast problem, and it depends on a lot of variables, some of them pre-existing, and we see in many of these rainfall events, you don't see a substantial damage unless there's antecedent conditions are very moist, or perhaps the rainfall is so extreme in terms of its intensity, like we saw with Harvey, where it just didn't matter whether you were dry ahead of time, you were going to see pretty catastrophic flooding. By all indications, extreme rainfall is increasing. The problem is trying to pinpoint exactly where that event may occur. But the magnitude or the intensity of these rainfall events does appear to be on the increase globally. It's a little more challenging to talk about that in terms of a smaller area like the continental United States, but certainly in the last few years, even in the short time I've been at the Weather Prediction Center, devastating flash flood events from heavy rainfall. So I don't think there's a lot of doubt that we're seeing an increase in the potential for those events, and that would go along with a warmer climate, which we're also seeing in the temperature record.
Well, thanks. That certainly that's very informative for us as to how we're seeing increased precipitation events due to more moisture in the atmosphere, which, as you said, goes along with a warmer climate currently. A number of attendees were wondering how come Maria didn't make the top 10 list.
Well, again, I always put a disclaimer at the beginning of my talk. Your memories may vary from mine. Maria is certainly a remarkable and devastating hurricane event, and there's no reason why it can't be in there. I usually put the events together before, and at that point it's only September, October, so I don't do a whole 10 events at that point. I do 8 or 9, and that got me up through Irma at that point. And then by the end of the year I will fill in number 10, and by that point the California wildfires took the 10th spot. Yeah, and sometimes I will go back and reevaluate, but for the most part, these are my memories, and that's my disclaimer.
Fair enough. And speaking of that, so far, and you may just want to pull one or two out, but how does 2018 look so far? Are we expecting more broken records in terms of impact due to extreme weather events? And if so, what few might you point to?
Well, so far, actually, not as active a winter, especially in the western United States. Much drier there than last winter. We have seen some pretty significant rainfall in the United States during March. Not a lot in the way of widespread severe weather so far. relatively active winter weather across the interior portions of the northeast United States. So an above normal snowfall and snowpack, and certainly a lingering winter across that area. Like I said, I'm starting to formulate a list in my head, but it's still early, and I usually don't get to reviewing these events until around August. So I've got a ways to go.
Okay. We have one attendee from Florida who is actually interested in getting an idea about hurricanes, and she writes that hurricanes seem to be increasing in strength over the last few years. Do you think that this trend is going to continue due to warmer waters?
Hurricanes are like any other meteorological phenomena. They're so dependent on many things, not just warm water, but the wind shear in the atmosphere or lack thereof, large-scale oscillations like El Nino, La Nina, and the tying hurricane development to climate, a warmer climate or warmer temperatures has proven to be quite a challenge. So I'm not going to make a prediction. NOAA will make a formal initial seasonal prediction coming up here, I think, in early May when they do their seasonal, and then they'll update that as we get closer to the season again. So I'm gonna let the experts give you some idea on hurricane activity as we move forward into the rest of the year. It was quite a remarkable year in 2017, but just like the stock market, past performance is no indication of future gain.
Very well. You know what? I have two other questions. I'm going to ask you one, and then I think the second you will probably be able to answer as you present some of NOAA's National Weather Service online educational and professional development resources for the educators. But this first question is about atmospheric rivers. And I don't know if you'll be able to answer this because as in our speaking prior about climate science, you mentioned that was not entirely your area of expertise. But the question is, what is the current climate science about atmospheric rivers? How much can be attributed to climate change? And can you say more about predictions for atmospheric river-caused heavy rain events for California?
I can speak a little bit to that, and actually some really interesting aspects of atmospheric rivers that we've just seen the past two. Atmospheric rivers have always been there. First of all, moisture is transported. The atmosphere is essentially a fluid, and you can see that by that loop early on where it shows the fluid motion as storm systems move through the jet stream and transport water vapor around the planet. And in a sense, the warmer climates of the subtropics, equatorial regions have much greater concentrations of water vapor because they're much warmer than the mid-latitudes and certainly the polar regions. But the circulation on the planet is basically there to try to balance the heat budget and move heat and moisture from the tropics to the poles in the form of extratropical cyclones and also tropical cyclones and hurricanes. And so these atmospheric rivers are part of that process. I think we've got a better understanding in the satellite era about these features of the atmosphere, and we measure them so the record isn't all that long with respect to what these things are doing, but there is an indication that we're probably seeing, just like we're seeing the increase in precipitation, we're seeing an increase in atmospheric water vapor content as you move north. It's more likely to see high values more frequently. Now that doesn't necessarily mean precipitation. So those atmospheric rivers that you see on the satellite are in the form of water vapor, but you really need lift and or something to remove that vapor from the air, or else it just is going to continue to move around like you see it. And so we've seen a couple of events recently where highly anomalous amounts of moisture were coming into the West Coast, but not really resulting in all that anomalous amounts of precipitation. And that is a very intriguing observation that we've just seen over the last couple of weeks. We've seen the conditions ripe for extreme rainfall, but because the systems weren't aligned correctly and the lift wasn't necessarily coincident with that moisture, you didn't get the moisture released from that atmospheric river. So those rivers can exist in the atmosphere, but it doesn't necessarily correlate to high precipitation. And we have a lot more to try to understand exactly what's going on there. And we now have some remarkable tools that allow us to do that.
Oh, well, thanks. So, you know what? I think that right now, how about we move on to finding out a little bit more about the educator professional development, as well as some classroom and just public education resources that we can get from NOAA's National Weather Service, and then maybe afterwards we can go back and take some more questions for you.
Okay, sounds good, Bruce. So I have to thank Mary Fairbanks from the Office of National Weather Service Communications for putting together the slides here. There are just almost infinite number of resources available for anyone interested in weather. And so starting here with the latest forecast information from weather.gov, local forecast offices across the country provide value-added content and social media posts, and you can even get the pinpoint accuracy of local forecasts on your mobile phone. So there are some of the links there. Whoops, what did I do here? Let's see, go back here. So seasonal awareness safety campaigns are put on for winter, severe weather, tropical weather, summer heat. I think that's another tropical one that they put on. But these safety campaigns, more information on those can be found at this link. And Bruce is going to have a copy of this going on, so you can take the links right now. MetEd is a resource on the MetEd. No, this is Weather Ready Nation training modules. So it is through MetEd. MetEd has a number of modules available. You do need to register on this site. It doesn't collect any information, but you do need to have an account in order to access that information from MetEd. And there's a tremendous amount of information available from them.
And it's free.
And it's free, right. Yeah, there's another website, the Comet MetEd website. And some of these go into a lot of detail. I mean, these are college level courses in some cases, describing atmospheric science and also climate science.
But many are usable at the high school level, right?
Yep, absolutely.
Yep.
Science and Safety for Everyone, and Weather Service Education Resources at Ali Skywarn's Ready page for younger students, and lots of other information on careers and publications, where to get brochures, maps, and so on. And that's youngmeteorologist.org, the site where students interested in all forms of weather can learn about that. And this was developed in partnership with the Weather Service, offering a learning environment that shows kids what they need to do to prepare and how to protect themselves and help their families when real storms come. I know a lot of meteorologists who got into the science because they were impacted by severe weather at an early age, or their families were. And if you love weather, there's plenty of resources here in participating in the science. I often tell students that I talk to that it's one of the easier sciences to become engaged in. Doesn't cost a lot of money, a thermometer and a rain gauge, and you're in business as an observer. Of course, nowadays with the internet, you can provide those observations to sites that provide databases. MPing is an interesting application that takes observations of precipitation type and correlates that to what's observed on radar. And the Community Collaborative Rain, Hail, and Snow Network is where you can archive observations of rain and snow. Many examples of data sources. I'm a data junkie. If you've got any questions, please follow through. But there is just a tremendous amount of information out there to dig into, to do data diving and data analysis with. Satellite imagery. EDD site provides observations and storm reports, climate data, surface analysis. That's what we do here at the Weather Prediction Center. The map in the middle is generated here at the Weather Prediction Center, and just an endless amount of data to work with in meteorology. And then the Weather Ready Nation program is seeking ambassadors. This is an initiative of extreme weather and water events, and motivating individuals and communities to take actions that can prepare them in the event of weather disasters. So this is a very useful site for that type of information. We work very closely with ready.gov as well, and the Federal Emergency Management Agency. And really the key to making it through some of these events that I've described here today is resilience and being smart in the face of ever-changing weather, especially severe weather. So if you have more questions, you can contact Mary at that email address or that phone number. And I thank you again, Bruce, for having me this evening. It's been a pleasure, and hope we've provided some useful information for those attending.
Oh yes, Greg. It was really interesting. I mean, I just hearing descriptions of the information that behind those events was terrific. We have a few more questions from people, and please, folks that are on the line, don't go away because we do have some important announcements at the end. But Greg, one question that we had from one of the attendees, she mentions that her students love extreme weather. Are there any student-friendly compilations like the one you just presented that are available from NOAA or another organization? And I can think of maybe one or two.
Well, you go ahead then.
Well, you know what I was going to say? I was going to give a plug for AMS, the American Meteorological Society, and
Sure.
have several excellent websites that focus on weather and weather events and weather educational resources as well, particularly some extreme weather. So you might want to check some of that out, as well as I believe the National Earth Science Teachers Association has a wonderful website called Windows to the Universe. And I believe that they also talk about some weather and extreme weather conditions as well. So people might want to check those out too.
And then there's the, I'll put a plug in for the National Weather Association, nwas.org. They're also very active, especially in operational meteorology, and also can be a resource for information regarding extreme weather. There is a lot of interest in extreme weather. It is interesting how it got a bit of a bump from, well, probably the Weather Channel and others, but also Discovery Channel had the storm chasing show on for a while. But that's not real. That's not real. So it is interesting that people have this vision that you can become a storm chaser and perhaps make a go of it, and maybe you can, but more often than not, that's probably going to be a disappointment. The real focus is on the science and on the forecasting operationally, and if you do that well, you might actually be able to partake in field operations as part of either a college program or even a research level program through the government. So there are these field campaigns that are available to students, but it takes a lot of hard work to get to that level.
Oh, absolutely. Now, we did have, you showed some excellent imagery, Greg, during your meteorological memories, and some of those were from satellite and radar imagery. And one question that came in was, how does one tell the difference between smoke/fire and clouds on radar? And what are some other, primary things that you look for regarding weather when you're looking at radar?
Well, radar has become incredibly sophisticated and advanced, even in a short period of a couple of decades. When I started my career, essentially we had the radar that could give us information about the distance and the distance from the radar location and the intensity of the storm. Not long after that, the Weather Service began to install the Doppler radar systems, which not only tell you about the intensity of rainfall or snow or hail, but they tell you the wind direction within the storm along the radial using the Doppler effect. So essentially the radar is sophisticated enough to record the change of the radar beam as it's returned to the radar, and that difference in frequency can give an idea of whether something is moving toward or away the radar, and that's the Doppler radars that are now in effect, now in use basically nationwide. There was an upgrade to that system called dual polarization, and so essentially instead of the radar beam going out, now goes out both horizontally and vertically. And so now not only do you have the ability to detect intensity and air motion from the Doppler effect, but this dual polarization of the radar beam allows the processing to occur in which it can determine the shape and character of what are called the hydrometeors within the storm or within the rain. You know, how large are those raindrops? So what's their shape? Or is it wet snow, or is it hail? And so this dual polarization has added another level of information coming from radar that can provide information on the character of the particulates that are being viewed by the radar. And so smoke shows up as one form on the radar, ice as another, rain as another, and these particulates, because of the different characteristics, return different frequency characteristics from the radar beam. So that's one way in which smoke can be detected. Using satellite imagery, the type of imagery we think of like taking a picture with our phones, a lot of satellite imagery is actually a measure of temperature. And there are bands on the geostationary satellite that actually detect very high temperatures associated with fire. And so you can actually combine the radar signature, if there is any doubt that you're looking at a smoke plume, with the satellite imagery to see if there's actually something hot there, and give you even greater confidence in what you're looking at as a fire, or maybe not. Maybe it's dust, or maybe it's birds or insects. So these different types of remotely sensed data, when combined, can be quite powerful in providing us observations of the atmosphere and the Earth.
So, Greg, in addition to some of these advancements in radar, certainly, one attendee has asked what you think, if you just had to pick a few, what have been the most significant improvements in forecasting tools that have occurred over the last, well, the most recent years?
That's a great question, and one that I enjoy answering. Satellite and radar have been around for a while, and even though that we've seen these remarkable technological advances in the use of those, the one area that, and I didn't talk about it very much in the talk today, but I have a whole other presentation on the content related to modeling and simulations and numerical modeling of the atmosphere. Now, when I started in meteorology, essentially the computing power wasn't sufficient to support really more than one deterministic global model, and it went out about 3 or 4 days, and that wasn't all that great. And it was really the only forecast you had of atmospheric conditions beyond the next day or so. Now we have literally dozens and dozens of numerical simulations of the atmosphere. You've probably heard of the European model. We have a global forecast model. New advances coming along all the time in numerical forecasting. What that allows us to do is combine these forecasts into ensembles, and what these ensemble systems allow us to do is actually, for the very first time as meteorologists, understand the predictability of the atmosphere. So instead of having a single forecast, we have a whole set of forecasts. And if those forecasts tend to all agree, then we can be relatively confident we're in a pattern that is more predictable perhaps than, say, forecasts that don't agree. And the measure of this difference is usually done in terms of probabilities, and probabilities can give us the certainty or uncertainty of particular events. So I would have to say that ensemble forecasting is probably the most dramatic advance that the science has seen, certainly in my career, and it doesn't show any sign of letting up. The capabilities are changing and advancing all the time.
So that's great. So the mathematical models, and let me just, as a quick follow-up, maybe you can give some perspective as to what how the level of granularity has increased from, say, when you were working way back when initially on some of these models and what they look like today.
Sure, and actually, that some of the more dramatic advances in the last, say, 10 or 15 years have occurred in our ability to model or predict the development of thunderstorms. So a typical thunderstorm is probably on the order, it's generally under about 10 kilometers in size or space. When I started in meteorology, the resolution of numerical models is probably on the order of about 150 or 200 kilometers. So you couldn't even discern a thunderstorm. In fact, these modeling systems, in a sense, they could discern mid-latitude cyclones, large-scale weather systems bringing about, larger rain. But we've advanced now to the point at which we can actually regularly generate numerical model forecasts for thunderstorm events. We're not quite down to I wouldn't say we're quite at the scale yet of individual thunderstorms or small scale, what are called supercells, but we're pretty close. And in fact, some of the high resolution models now depict characters that depict features within the model that are very, very similar to individual thunderstorms and that show rotation similar to those that we see for tornadic thunderstorms and large hail producers like we saw with the Denver event. And so there's just been a really dramatic capability of going down in scale and being able to discern and simulate some of these small scale features that we see in the real atmosphere, and some of these small scale features are some of the most dangerous as well.
Huh. Well, thanks, Greg. I mean, that's I mean, it's comforting to know that we can certainly get a better sense of what's going on a much more localized level with some of this extreme weather, so that we can be even more prepared. And be more resilient in our efforts to protect both ourselves, our loved ones, and our communities. And if you can just hang on for just a little while, Greg, we'll just see if any other questions come in from people. But there were quite a few people who showed up a little bit late, and what I'd like to do is just remind everyone who came in of some of the things that we have going on. Please, everyone, check your email. You've gotten a link to our post-webinar poll. If you could do it right now, that would make me and our entire program very happy, so that we can continue to bring you these types of programs in the future. On Tuesday, May 15th at 7:30 Eastern Time, we've got our next Planet Stewards webinar, Water Quality, Shellfish, and You. And on Monday, May 21st at 8 p.m. Eastern Time, we have our next book club meeting, Please Don't Paint Our Planet Pink. And if you'd like to join the discussion, please contact Stephan at gmail.com. It's a great book for students, and it'll be a great discussion as well. I mentioned earlier on that NOAA Planet Stewards will be sponsoring and working on 3 workshops this summer. We've got the Changing Southwest Environment, Trends and Challenges, June 11th through 13th in Flagstaff, Arizona. If you want more information or to register, there's the link. Don't worry, you don't have to copy it down now. You'll get it in the archive that I'll be sending you. Also, Environmental Impacts to the Gulf Coast. What do we know? What can we do? That's going to be down in the I'm not sure how that's pronounced exactly. La Marque, Texas. It's in the Houston Galveston area. It's June 25th through the 28th. And there's also more information and where you can register here. And finally, we've got Resilience, Education, and Action, Our Place in a Changing World. And there's going to be a pre-symposium event with limited registration of only 40 people, July 21st through 22nd. You don't want to miss that. Or the full-blown symposium on July 23rd, and both of those will be held on the island of Oahu in Hawaii. And then finally, just as I've mentioned again, if you're on the East Coast, sponsored by NOAA, Delaware Sea Grant, and Made Clear, there's going to be a 2018 Climate Change Academy. And what's great about this is that there's a self-paced online component that starts Monday, May 21st, as well as a face-to-face component June 26th through 28th at the University of Delaware in Lewes, Delaware. And I have to tell you, I have done one or two of these before, and they are tremendous. It's great staff. They cover many topics, face-to-face time with a lot of climate scientists, educators, and communications expert. In addition to getting free education materials, there is a $300 stipend if you complete everything. So you get the information, you get the resources, and if you complete all the requirements, you get money. Does it get better than that? I don't know. So, and you can register for that right now if you like. So, and you know what? While we go back and see if there are any other questions, I want to let everybody know that every full moon, every 28 days, NOAA puts out this great compilation of resources, and it's through Ocean Today every full moon. And for Earth Day this year, there's a special, The Ocean We Love, and it is a compilation of compilations focusing on the importance of the ocean and what we can do to try and aid it and the creatures inside it to maintain its health, because the ocean's health reflects back and is our health in turn. And if you'd like to go see that, you can just Google NOAA Ocean Today every full moon, or you in fact do have the full link right at the top there in yellow. And finally, it has been, for some of us in the Northeast, a long winter, and hopefully in other parts of the country too, you will be seeing the crocuses coming out for spring. So I thought that while we went back to Greg in a moment, we could just share some of this imagery with you. And I will still be taking questions, but now I'm going to be ending the official recording. And I would like to thank everyone who joined us this evening. We look forward to seeing you all in May, and we hope everyone will be having a very good spring into summer. So thank you all.